Guys, can you please check if the recording is on from my side?
Yes, it's on.
Okay, cool. Hello, Risha. Good morning. Yeah, so it's 11:10 and I think we should start the class now. So, hello, am I audible?
Yeah,
Yes.
Cool. Cool. So in the last class, we were discussing this Fourier series, which is quite an important topic on the point of view of knowledge as well as examination. Since I told you guys कि Fourier series का use will be using in Fourier transform, and Fourier transform का use will be using in solving the higher order Schrodinger equations of quantum mechanics. So in the last class, we left us this question called f of x is equals to x cosine of x, whose range is given minus pi to pi. We have to find the Fourier series expansion for the function in the given range minus pi to pi. So since we know this cos x, this is an even function, fine. But when this here is multiplied by this vector called x, so it becomes an odd function. And we know for an odd function, the very first term in our Fourier series, which is a naught, and the rest of the terms of an becomes 0. In the last class, we had derived how they become 0. So, we just need to find this bn factor in this whole x cos x science Fourier series expansion. So, we have the formula for this bn, which is 2 by pi integration 0 to pi. We'll be just putting this x cos x in the formula of Bn, which is first of all we have to find a naught and an, which is clearly 0. So we are just focusing on this part of Bn. I hope you both know the formula. So this is like Bn 2 upon pi integration 0 to pi. What I have done, I have changed the limits, like it's a minus pi to pi. So I'll be doing 0 to pi, and I have multiplied this factor 2, since I have changed the limits from minus pi to pi. Yeah, so 2 over pi 0 to pi will be integrating this x times sine of n plus 1 times x dx plus 1 over pi 0 to pi x times sine n minus 1 times dx. So now what we have to do, we just have to simply integrate this term. Bn is 1 over pi 0 to pi x times sine n plus 1 x dx plus 1 over pi, integration is same, 0 to pi x times sine n minus 1 times dx. We'll be using the Leibniz rule. I hope both of you know what the Leibniz rule is. Yeah. So first of all, we have to take the derivative of this term. Then we have to integrate this term, and we'll be doing this until unless we get our solution, which is like quite compatible. And then we'll be putting the given limits in the series, and we'll get our answer. So integrating this by Leibniz rule, we get 1 over pi. This as it is. Sine into n plus 1 ka integration is what? Minus cos times n plus 1 upon n plus 1 plus, now we have to derivate this derivative of this and integration of this term again. This is the only Leibniz rule we have been following in the previous class also. Sine of n plus 1 times x over n plus 1 ka square. I just have to integrate this. This is 0 to pi plus, now this term 1 over pi minus x times cos of n minus 1 over n minus 1. We have x here plus sine of n minus 1 times x over n minus 1 ka square. Yeah, we'll be putting the limits now. By Leibniz rule, we have done this quite simple integration, and now we have to put the value of given limits, which are 0 and pi. So we'll be solving this. Bn is what? 1 upon pi x times minus cos of n plus 1 times x over n plus 1 minus cos of n minus 1 times x over n minus 1 plus 1 sine of n plus 1 times x over n plus 1 का square. I just know like साइन वाले टर्म एंड कोसाइन वाला टर्म मैंने इसमें अलग अलग कर दिया, प्लस साइन ऑफ n minus 1 times x over n minus 1 square. Yeah, limits 0 to pi. After putting these limits, what I'll get, Bn is, I hope you know that sine of n pi is 0. and cos of n pi is minus 1 to the power n. Using putting the limits and using both these integration, the value of bn becomes 1 up over pi times minus cos of n plus 1 pi over n plus 1 minus cos of n minus 1 times pi over n minus 1. Putting these things, bn is what? This will be pi से pi cancel हो जाएगा. We'll get minus 1 to the power n plus 1 over n plus 1, negative sign here, minus 1 to the power n minus 1 over n minus 1. Yeah. So in this value of bn, if we put n is equals to 1, this whole will vanish. Like the value of bn will go 0. So in this we cannot put n is equals to 1. Fine. So the general formula of Bn becomes minus 1 to the power n plus 1, commonly लिया सिर्फ 1 upon n plus 1 minus 1 upon n minus 1. Yeah. So this is the general formula of Bn. What we have to do, we just have to simply put the value of n, which is an odd function. So n ka odd function is, we already know this is an odd function. So it is clear that we'll be using the n is equals to 1, 3, 5, 7 odd terms only. Fine. Guys, give me a minute. Yeah, sorry. So what I was saying, so since the x cos x is a odd function, so it's clear that we'll be using the odd values only, like n is equals to 1, 3, 5, 7, and we'll be expanding our cosine this general formula in the n is equals to odd only. Fine. Yeah. So in the next part of this Fourier series, we have this very famous theorem called Parseval's theorem. Fine. I hope this is clear to you. Hello, hello. So the next part of our discussion will be doing the Parseval's relation. Since we know that we can express a function f of x ka square with the multiplication of this conjugate function like the complex function and the function itself. So we can write if we are given some limits a to b for some function f of x ka modulus square dx, we can write it as a to b f of x times f of this complex function of f of x. Fine. So in the last class we derived the formula of both f of x and f star x. So we'll be using that formula a to b. This will be same f of x ka square dx. The same limits will be using the Fourier series formula of this f of x and f star x, which will be a naught by 2. First I'm opening this one, a naught star by 2 plus integration n is equals to 1 to infinity an star cos of 2n pi x over L plus bn star sine 2n pi x over L. I have elaborated this one. Now I'll be multiplying the function with iska value. It will be something like a naught by 2 plus integration m is equals to 1 to infinity cos of 2m pi x over L plus bm of sine 2m pi x over L dx. Yeah. Now, since we know will be when we'll be doing this integration of a naught by 2, which is a complex function. Fine. This symbol here represents the complexity. We'll be further solving this. We'll get f of x square dx on the limits a to b. We'll be getting a naught square by 4 times L. L here basically represents the difference between our limits. L is equals to a minus b. A naught square by 4 times L plus integration n is equals to 1 to infinity. The complex function of a n integration n is equals to 1 to infinity am of cos 2n pi x over L times cos 2m pi x over L times dx. We have the limits here, a to b, yeah, plus this is the an term. Now we'll be going the same with the bn term. N is equals to 1 to infinity bn star integration m is equals to 1 to infinity limits a to b bm times cos of, sorry, the cosine terms are used, so here we will be using sine terms. Sine of 2n pi x over L times sine 2m pi x over L times dx. Yeah. Now we will further solving this, since we know that cos of n pi is equals to minus 1 to the power n and sine of n pi is equals to 0. So we'll get integration a to b f of x square dx is equals to a naught square by 4 times L plus 1 over 2 integration n is equals to 1 to infinity. We just got this an square plus bn square. We'll be using the modulus of both of terms. We simply got the formula, which implies a naught square by 4 plus 1 by 2 integration n is equals to 1 to infinity an square plus bn square, which is equals to this one. L उधर चला जाएगा, डिवाइड में हो जाएगा 1/L a to b f of x square dx. Yeah. So this is the general relation of Parseval's relation. We call this the Parseval's identity. Identity, and the use of Parseval identity is to find, basically we'll be using this to find the value of the whole series. Like if we are asked what is the value of 1 plus 1 by 2 square plus 1 plus 1 by 3 square for some given function, like it must be a function for sure, since Fourier series किसी function का ही होता है. So let's take this example जिसके अंदर हम अपनी Parseval's identity का use करते हैं. So the very general question which comes in exam, it is question number 1, which is f of x is equals to 1 and in the given limits 0 to pi, and we have to prove that pi square by 8 is 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square integration. Yeah. So since we know this is an even function, this is an odd function again. So we just need to find the value of bn only. Solution. The value of bn is 2 over pi integration 0 to pi f of x times sine nx dx. Again, we'll just put the value of fx, which is 1. Bn is 2 over pi integration 0 to pi 1 times sine nx dx. This simply becomes Bn is 2 over pi 0 to pi sine nx dx. Sine nx का हम इंटीग्रेशन करेंगे, we'll get 2 over pi. Sin x का integration is what? Minus cos nx upon n. In the given limits 0 to pi, we'll get Bn is minus 2 over n pi cos of n pi minus 1. Since we know cos of n pi is minus 1 to the power n. So Bn is minus 2 over n pi minus 1 to the power n minus 1. Yeah. So this is the value of Bn which we have got here. If we put uh, n is equals to some even value, we'll be getting the whole Bn as 0. And for n is equals to even, this will be like Bn is equals to 0 if n is some even value. You can put it like if you put here 2, so minus 1 ka square is what? 1, 1 minus 1, 0, the whole Bn terms vanishes. If Bn is some odd function, like if n is odd value, so Bn will be what? 4 over n pi. So we'll be using this term only for the Fourier series expansion since the even term vanishes. Fine. So we were asked to, if we put this Bn is equals to 4 over n pi in the general formula of this, Fourier series, we'll be getting 1 is equals to 4. This 1 here is what? F of x. We represent what? F of x is equals to a naught by 2 plus a n times sine 2n pi l over x dx इंटीग्रेशन वाला टर्म वो सब वैनिश हो जाएगा, सिर्फ bn वाला टर्म आएगा और लेफ्ट हैंड साइड में हमारे पास fx होता है, उसके जगह we have put our the real value for function which is 1. So it will be 4 over pi sine x plus 4 over 3 pi sine 3x, just the old values we are using here, fine, plus 4 over 5 pi sine 5x plus 4 over 7 pi sine 7x, it goes, fine. So if we use the Parseval's identity here, we'll be getting what? Using Parseval identities, Parseval identity में limits will be using 0 to L. L is what? A minus B f of x का square dx is L by 2 b1 square plus b2 square plus b3 square. I'm not using the an wala term here since an is 0 here. We'll be getting our function is 1, so 1 ka square is 1 and 1 ka integration in the given limit 0 to pi 1 square dx is L is what? Pi minus 0, which implies L is pi. Yeah, so pi by 2 integration 4 over pi square plus 4 over 3 pi square plus 4 over 5 pi square up to so on. Yeah, so we'll be using this. This will be x, the integration or limit 0 to pi. It will be pi by 2. 4 को बाहर ले 4 का square by 16. 4 का square 16 और pi square को हम common ले लेते हैं. So it will be 16 by pi square. Will be remain with 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square and it goes on. Yeah. So it will be what? This will be pi is equals to pi by 2 times 16 over pi square. This 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 17 square up to so on. Yeah. So इधर से cancel हो जाएगा. It will be 8. हम इसको right hand side में ले जाएंगे. We'll be getting pi square by 8 is equals to 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square up to so on. Yeah. So this is the value of this given Fourier series for f of x is equals to 1, hence proof. Yeah, so we were given this f of x is equals to 1 as our function. जिसमें we know such bn का term बचेगा since it's an odd function. So this is the value of the bn. We just elaborated this with a very famous formula of Fourier series. Then we use the Parseval identity. Parseval identity के अंदर a square का term भी आता है plus उसके साथ में summation of bn का term भी आता है. But given function के अंदर an का value 0 है. So Parseval identity के अंदर भी we just have used the value of b1, b2, b3 B1, B2, B3 का वैल्यू इज व्हाट? 4 upon pi, 4 upon 3 pi, 4 upon 3 pi, 4 upon 7 pi to so on. हमने सिर्फ वही यूज करा है. We have put the value of L, which is A minus B, which is pi minus 0. So L vanishes to pi. So this is the value we have got for this question. In the next question, yeah, which says f of x is pi x and pi of 2 minus x. कई बार क्या होता है क्वेश्चंस के अंदर अलग अलग लिमिट्स गिवन होती है, जिससे वो जो फंक्शन है वो दो या फिर तीन पार्ट्स में डिवाइड हो जाता है. फाइन. सो इस क्वेश्चन इस पार्ट के अंदर जो लिमिट है दैट इज 0 ग्रेटर देन x ग्रेटर देन 1, विच इज फॉर दिस पाई ऑफ 2 माइनस एक्स. इसके लिए हमारे पास लिमिट्स गिवन है 1 लेस देन x 2. या सो इसके अंदर this is a very simple question. We'll be finding the value of an, bn and a naught. प्लस इसके साथ हमें प्रूव करना है कि यूजिंग पार्सीवल्स आइडेंटिटी we have to prove pi to the power 4 by 96 is 1 plus 1 by 3 to the power 4 plus 1 upon 5 to the power 4 plus 1 upon 7 to the power 4 up to so on. Yeah. So in this question, we'll be finding first of all a naught solution. Yeah. So a naught is what? 2 over L integration 0 to L f of x dx. इसके अंदर हमारे पास a नॉट में दो टर्म्स आएंगी. पहली पाई एक्स वाली आएगी, दूसरी पाई ऑफ 2 माइनस एक्स वाली आएगी. और दो दो लिमिट्स हम यूज करेंगे. लाइक पहले हम 0 टू 1 के बीच में सॉल्व करेंगे, फिर हम 1 से 2 के बीच में सॉल्व करेंगे, क्योंकि हमारा जो फंक्शन है उसके पास दो लिमिट्स हैं, एक 0 से 1 और एक 1 से 2. सो फर्स्ट ऑफ ऑल विल बी यूजिंग पाई पाई एक्स के साथ 0 से 1 वाली यूज करेंगे. पाई ऑफ 2 माइनस एक्स के साथ हम 1 से 2 वाले लिमिट यूज करेंगे. सो it explains 0 2 by L. L is what? 2. इस लिमिट के अंदर we have got L is equals to 2, 2 over 2 integration 0 to 1 pi of x dx plus 1 to 2 pi of 2 minus x times dx. Yeah, simple. Simple. Integrate करते हैं. We'll be getting a naught is what? Pi x square by 2 0 to 1 plus pi 2x minus x square by 2 with limits 1 to 2. Just putting the value of limits, we'll get pi by 2 plus pi times 4 minus 2 minus 2 minus 1 by 2. Yeah, simple. A naught is what? Pi by 2 plus pi times this is what? 2 minus 4, 4 minus 1 is but 3 by 2. We'll be simply getting A naught as pi. Yep. Now we'll be finding the value of an for this function. इसके अंदर bn वाला term will be vanishing. Now we have a bn is what? Obviously 0. Next an is 2 over L 0 to L f of x cos of n pi x over L times dx, which is the general formula of a cosine series we learned in last class. कोसाइन फोरियर सीरीज. यप. इसके अंदर जो बी एन वाला टर्म है वो जीरो हो जाता है. बी एन के साथ कौन सा फंक्शन आता है? साइन फंक्शन आते हैं. सो अगर हमारे पास ए नॉट और ए एन जीरो होता है तो वो एक साइन सीरीज बन जाती है. और अगर हमारे पास बी एन वाला टर्म जीरो होता है तो दैट बिकम्स अ कोसाइन फोरियर सीरीज, क्योंकि ए एन हम निकालते हैं जिसमें कोसाइन फंक्शन आता है. सो दिस इज द ओनली रीजन हम इसको कोसाइन फोरियर सीरीज और कोसाइन साइन सीरीज में कैसे डिफरेंशिएट कर सकते हैं. We'll be using the value of the function. It will be 2 over 2. L का value is what? 2, 0 to 1 pi times x cos n pi x over 2 times dx plus 1 to 2 pi of 2 minus x times cos of n pi x over 2 dx. Yep. Putting the value of function an is what? Pi times इसको integrate करते हैं x into sin n pi x over 2 अपॉन अभी इसका फंक्शन क्या होगा, एन पाई बाई टू, इंटीग्रेशन करा है हमने, सिंपल, माइनस अभी एक्स का डेरिवेटिव इज व्हाट, वन, इस पूरे का इंटीग्रेशन इज व्हाट, माइनस कॉस एन पाई एक्स ओवर टू ओवर एन स्क्वायर बाय फोर with limit 0 to 1 plus now this function pi times 2 minus x sine n pi x over 2 over this function n pi by 2 minus इसका differentiation minus 1 into minus cos of n pi x over 2 upon इसका इसका this function n square by 4, simple, yeah, and here the limits are 1 to 2. Now we'll be simply putting the value of limits. An is what? Pi times 2 over n pi, 2 over n pi, sine n pi by 2 plus 4 over 2n pi square, cos of n pi by 2 minus 4 over n square pi square. Simple. Plus pi 0 minus 4 over n square pi square, cos of n pi minus 2 over n pi sine of n pi by 2 plus 4 over n square pi square cos of n pi by 2. Yeah. Solving this, we'll be getting an is pi times 4 by 2 and 4 by 2, and this will be 8 over n square pi square cos of n pi by 2 plus minus of 4 by n square pi square cos of n pi minus 4 over n square pi square. Yeah, simple. We'll be putting cos n pi or sin n pi का value, sin n pi तो है ही नहीं, simple. So an is 4 over n square pi square, मैंने कॉमन ले लिया, इधर से और इधर से, ठीक है, पाई था ही, पाई से पाई कैंसिल हो जाएगा स्क्वायर वाला, so this will be 2 cos n pi by 2 minus 1 minus cos of n pi. Yep. So we'll be getting a1 is equals to 0 if you put n is equals to 1. We'll be getting a1 is equals to 0. If we put n is equals to 2, we get a2 minus 4 over pi. If we put n is equals to 3, we'll be getting a3 is equals to 0. If we put n is equals to 4 here, this will be a4 is 0. Again, if we put n is equals to 5, we'll be getting 0, and if we put n is equals to 6, we get minus 4 over 9 pi. Yeah, so if we use a Parseval's identity here, we get 0 to L f of x square times dx is L by 2 a naught square by 2 plus a1 square plus a2 square up to so on. Yeah, we'll be putting f of x का दो वैल्यू था, pi x और 2 minus x with given limits 0 to 1 and 1 to 2 respectively. So we'll be integrating it, 0 to 1 pi x square dx plus 1 to 2 2 minus x time pi square dx is equals to 2 by 2. L is what? 2. 2 by 2 times pi square by 2 plus 16 by pi square plus 16 by 81 pi square up to so on. Yeah. So solving it, we'll be getting pi square bahar, x का square का integration is what? X का cube upon 3, 0 to 1 minus pi square 2 minus x cube over 3 का square, yep, is equals to pi square, it will be cancelled, pi square by 2 plus 16, simple, we just have to multiply it, 16 over pi square plus 16 over 81 pi square up to so on. This term को, we'll be putting this value of series, we'll be getting pi square by 3 minus pi square of 0 to this is 0 to 2. Yeah, sorry, 1 to 2. So we'll be getting 0 minus 1 by 3 here, which will be pi square by 2 plus 16 by pi square up to so on. एक और टर्म लिख लेते हैं. Yep. So here we have got 2 pi square by 3 minus pi square by 2. अगर हम यहाँ से 16 by pi square कॉमन ले लेते हैं, we'll be getting 16 by pi square 1 plus 1 by 3 to the power 4 plus 1 upon 5 to the power 4 plus 1 upon 7 to the power 4 up to so on. ठीक है, we'll be solving this. We'll be getting pi square by 6 into pi square by 16 is equals to 1 plus 1 by 3 to the power 4. Yep, 1 upon 5 to the power 4 up to so on. We'll be solving this. We get pi to the power 4 over 96 is 1 plus 1 by 3 to the power 4 plus 1 upon 5 to the power 4 plus 1 upon 7 to the power 4, which is the required proof we have to do. So hence proof. Yep. So this was the question. Yep. So we have done two questions of this Parseval's identity in this class along with question which we left in the last class. We have discussed the basic Fourier series का expansion along with two examples of this. उसके बाद we discussed this Fourier sine series, Fourier cosine series, and in the last class we have discussed this all. Along with it, today we discussed this formula of Parseval's identity. We use this formula, and I think this much is only in your syllabus, और इसके अलावा कुछ और भी है extra. Let me just check from your syllabus. Yeah, so we have done periodic functions, orthogonality of sine and cosine function, Dirichlet conditions we have done, statement also we have done. हमने साइन और कोसाइन फंक्शन का अलग से डेफिनेशन कर लिया था, उनका वैल्यू निकालना सीख लिया था, फोरियर कोएफिशिएंट्स का इवन और फंक्शन हो गया था, उसका भी डेरिवेशन हो गया था, फोरियर कोसाइन सीरीज और फोरियर साइन सीरीज हो गया था. इसके बाद पार्सेवल्स आइडेंटिटी एंड इट्स एप्लीकेशन टू इनफाइनाइट सीरीज. या so we have covered almost everything from this unit 1, and I think that's all from my side for Fourier series. Now, like one of my classmates Rahul will be continuing with this next chapter called Frobenius method and the special functions. So this is the end of the class. Thank you so much. If you have
Thank
any
you.
more doubts, you can, just ping on my WhatsApp number I have shared with you guys, or you can ask like right now from the class if you have any doubts. Okay, I assume everything is clear to you from the Fourier series. In case you have doubts, you can guys contact me. So thank you so much. Bye. Thank you.
Thank you, Bhaiya.
Okay, bye.